Now let's move on to the next case, that is division. Now we'll move on to the next case, that is division. Before going into the topic, before going into the case, or before finding the error or maximum possible error in the resultant when we are dividing two quantities, we have to understand some concepts. Yes, there is a concept in maths called binomial equation or binomial expansion. We have been learning some identities. We have been learning some identities since school days. Say for example, a plus b the whole square or a plus b the whole cube. Likewise, isn't it? We have been learning such types of identities since school days. What is a plus b the whole square is equal to, or what is a plus b the whole cube is equal to? How do we find? We simply expand this bracket. Is it? We simply open these two terms or open these two brackets. We simply multiply each and every term in one bracket with each and every term in the other bracket for expanding or for finding what is a plus b the whole square is equal to. Similarly, for finding a plus b the whole cube, yes, first we will find what is a plus b the whole square is equal to, and then we will multiply a plus b with what is a plus b the whole square is equal to. Suppose you are asked to find a plus b the whole power 16. Suppose you are asked to find a plus b the whole square 16. Yes. How do you find it? You have to find what is a plus b the whole square, then what is a plus b the whole cube, then you have to find a plus b the whole power 4. Likewise, it goes on up to a plus b the whole power 16. It is very hard to find in such a way. It is very hard to find what is a plus b the whole power 16 in that method. Suppose you are asked to find a plus b the whole power 50. How do you do this? 50 times you multiply a plus b, 50 times you multiply a plus b, a plus b, a plus b. Is it easy? No. For making this calculation, we have a concept in maths called binomial expansion. Yes. Here actually we are not going to learn binomial expansion in detail. Here actually we are going to learn what is needed for our physics paper for the time being. Yes. So we will discuss binomial expansion or binomial equation in detail when we are dealing with this particular chapter in maths paper. So now let's see what is the binomial equation. What is binomial equation, or how do we find if we are asked to find a plus b the whole power n. N can be any value, a plus b the whole power n. This n can be any value. So what is this is equal to? This is equal to sigma k is equal to 1 to n. No, k is equal to 0 to n. K is equal to 0 to n. N c k a power k into b power n minus k. N c k a power k into b power n minus k. So this equation is known as binomial equation. So this particular equation is known as binomial equation. And also using this equation, yes, you can easily find the value of what is a plus b the whole power n is equal to, n can be any value starting from 0 to infinity. Is it clear, guys? Yes. Now at least some of you guys might be thinking, what is this NCK? What is this NCK? Again, in maths we have two concepts called permutation and combination. We'll discuss permutation and combination in detail when we deal with the chapter permutation and combination in maths paper. Now for the time being, you just understand we have two concepts in maths, that is permutation and combination. We have two terms in maths called permutation and combination. For representing permutation we use the letter P, and for representing combination we use the letter C. So it is clear that here we are representing combination. Here we are representing combination. Yes. So now what is nck is equal to, again for nck we have an equation that is n factorial divided by n minus k the whole factorial into k factorial. Is it clear, guys? Is it clear what is the equation of nck? What is the equation for finding combination? Yes, nck is equal to n factorial divided by n minus k the whole factorial into k factorial. Suppose you are given 18c5. Suppose you are asked to find 18c5. Yes, how do you find the value of 18c5? 18 factorial divided by 18 minus 5 factorial, 5 the whole factorial into 5 factorial. Is it clear, guys, up to this? Yes. Now the next question is, what is this? This notation. This notation is nothing but factorial. Again, we have another concept called factorial in maths. What is factorial of a value is equal to? Factorial of a value is nothing but the product of the numbers. The product of the numbers is starting from 1 up to that particular number. Say for example, if you are asked to find 8 factorial. So what is 8 factorial is equal to? Starting from 1 we have to find the product of numbers up to the given value. Up to the value you are asked to find the factorial. 8. Is it clear? Is it clear? Suppose you are asked to find 5 factorial. What is it equal to? 1 into 2 into 3 into 4. Starting from 1 up to the asked value or given value. Is it clear, guys? Factorial combination. Factorial combination, the equation of combination, is it clear? Yes. Yes. So let's expand this particular term. Yes, how do we get the values? Yes. What is the first value of k? The first value of k is 0. The first value of k is 0. nc 0, a power k. A power k means a power 0. A power k point b power. A power k point b power n. Okay. Sorry. Here n minus k and here k. A power n minus k. Here a power n minus k. B power k. So here a power n minus 0, a power n minus 0 and here b power 0. Is it clear? Next one is nc1. nc1 into a power n minus 1 b power 1. The next term is nc2 into a power n minus 2 into b square. It goes on like this. And extends up to ncn. A power n minus n, that is equal to 0 into b power n. Is it clear, guys? Yes. Now let's apply this equation for finding what is a plus b the whole square is equal to. A plus b the whole square is equal to. Before applying the equation for finding what is a plus b the whole square, here we have to remember some points. That is 0 factorial is equal to 1. 0 factorial is equal to 1. 1 factorial is also equal to 1. 0 factorial is equal to 1 and 1 factorial is also equal to 1. Is it clear? Again, you have to remember some more points also. That is nc0 is equal to 1. The value of nc0 is equal to 1. Yes. How do we get this? We can apply in this equation n factorial divided by n minus 0 the whole factorial into 0 factorial. We know n factorial is equal to n factorial. N minus 0 is equal to again n factorial into 0 factorial. So these two values will get cancelled. What is 0 factorial is equal to? Yes, just now we saw. So 1 factorial, 1 divided by 1, that is equal to 1. So thus we got the value nc0 is equal to 1. Again, nc1 is equal to 1. The value of nc1 is equal to 1. So we can let us check n factorial divided by n minus 1 factorial divided by 1 factorial. N factorial divided by n minus 1 factorial into 1 factorial. We know 1 factorial is equal to 1. Yes. Now it is given n factorial into n factorial divided by n minus 1 factorial. Suppose, let's see an example. It is given 8 factorial divided by 7 factorial. It is given 8 factorial divided by 7 factorial. Yes, we can say 8 factorial is equal to 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. Isn't it? Yes. What is 7 factorial is equal to 1 into 2 into 3 into 4 into 5 into 6 into 7. So what is 8 factorial is equal to, we have to multiply all the numbers starting from 1 to 8. Again, what is 7 factorial is equal to, yes, we have to multiply all the values starting from 1 to 7. We can say 8 factorial. 8 factorial is nothing but 7 factorial into 8. Isn't it? We can say 8 factorial is nothing but 7 factorial into 8, or otherwise we can say 6 factorial into 7 into 8. 6 factorial into 7 into 8, or we can say 5 factorial into 6 into 7 into 8. Likewise it goes on. Isn't it? Yes. Similarly, in the case of n, we can say n factorial is equal to n minus 1 factorial into n. Isn't it? 8 factorial is equal to 7 factorial into 8. What is 7 factorial? 8 minus 1 factorial is 7 factorial. N minus 1 factorial. What is 8? 8 is the value n. Yes. So here we have n minus 1 factorial in both numerator and denominator. So these two values will get cancelled. These two values will get cancelled. So we'll get nc1 is equal to n. So we'll get nc1 is equal to n. Is it clear, guys? Yes. Now the next one is ncn. Next one is ncn. How do we find ncn? Yes, ncn is equal to n factorial divided by n minus n the whole factorial into n factorial. So 1 divided by 0 factorial, that is equal to 1. So what is the value of nc0? nc0 is equal to 1, ncn is equal to 1. And what is the value of nc1? nc1 is equal to n. Is it clear, guys? Yes. So now let's find the value of a plus b the whole square using this binomial expansion. Okay. Using this binomial equation, not expansion, equation. Here sigma k starts from 0 and here the n value is 2. Again n c k a power n minus k, here the value will be 2 minus k b power k. Is it clear, guys, up to this? Now I am going to expand this term. So the first value n, here the value of n is 2. So 2c0 a power 2 minus 0 into b power 0. So this is the first term. The next term is 2c1 into a power 2 minus 1 b power 1. The next one is 2c2 a power 2 minus 2 b square. Is it clear? Yes. Now I am going to solve. We know 2z0 is equal to 1. So here I will get a square because b power 0 is equal to 1. 2 0 is equal to, so 1 into a square into 1. Yes, we will get a square plus 2c1 is nothing but 2ab plus 2c is nothing but 1. So that is equal to b square. Here we will get 2c2 is equal to 1, a power 2 minus 2 is equal to 1 into b square is b square. Thus we got the value, thus we got the expansion of a plus b the whole square, a square plus 2ab plus b square. Is it clear, guys? Binomial equation? Yes. Now We have so many special cases. We have so many special cases in binomial equation. We have so many special cases in binomial equation. Let's see one special case. Let's see one special case which is needed now for finding how the errors will get combined when we are dividing two physical quantities. The special case is nothing but 1 plus a the whole power n. 1 plus a the whole power n. So how do we expand this? K is equal to 0, here n. N c k, here instead of a we can write 1 the whole power n minus k, and here a power k. Isn't it? Yes. Here we know 1 to the power of any value. 1 to the power any value is equal to 1. So we can ignore this term. There is no need of writing this term. So we can say what is the binomial expansion of 1 plus a the whole power n, that is equal to sigma k is equal to 0 to n c k a power k. Now I am going to expand this particular term. Yes. So we can say nc0 a power k, nc0 a power k plus nc1 a, not k here, nc0 a power 0 a power 1 nc2 a square plus nc3 a cube plus it goes on like this up to ncn a power n. Is it clear up to this, guys? Yes. Now I am going to find what is nc, all these combination terms, and what is nc1 is equal to, what is nc2 is equal to, what is nc3 is equal to, likewise. Yes. So we know nc0 is equal to 1 and a power 0 is also equal to 1. So we will get 1 plus. What is nc1 is equal to? Nc1 is equal to, we know it is n. So we will get na plus. Now what is nc2 is equal to? Yes, let's find out. N factorial divided by n minus 2 factorial into 2 factorial. Isn't simply substituting the values of n and k in the equation of combination. What is the equation of combination? n ck is equal to n factorial divided by n minus k factorial into k factorial. Simply I substituted the values of n and k in this particular equation. So I got the value as n factorial divided by n minus 2 factorial into 2 factorial. Yes. Just a while before we discussed what is 8 factorial divided by 7 factorial, or otherwise let it be 6 factorial. 8 factorial divided by 6 factorial. Yes, just a while before we saw, we can write 8 factorial. We can write 8 factorial as 7 factorial into 8, or otherwise we can write 6 factorial into 7 into 8. 6 factorial into 7 into 8. Or we can write 5 factorial into 6 into 7 into 8. Is it clear? Suppose I am considering this 8 as n. What is 7 is equal to? 7 is equal to n minus 1 factorial. So what is n factorial is equal to? We can say n into n minus 1 factorial. N factorial is equal to n into n minus 1 factorial. Or otherwise, so I am considering 8 as n. So what is 7? 7 is n minus 1. So here what is 6? 6 is equal to n minus 2. Again we can say n factorial is equal to n into n minus 1 into n minus 2 factorial. N minus 2 factorial. Suppose I am considering 8 as n, we can say 7 is 1, n minus 1, this is n minus 2 and this is n minus 3. So we can also say n is equal to n minus 1 into n minus 2 into n minus 3 the whole factorial. It goes on like this. Is it clear, guys? Yes. So here we have n minus 2 in the denominator. Here we have n minus 2 in the denominator. Isn't it? Yes. So how can you write n factorial? How can you write n factorial in the terms of n minus 2 factorial? We can write n minus 2 factorial into n minus 1 divided by n minus 2 factorial into 2 factorial. Is it clear guys, this particular step? We can write n factorial. We can write n factorial as product of n into n minus 1 into n minus 2 factorial. Yes. So these two terms will get cancelled. So what is 2 factorial is equal to 1 into 2 is equal to 2. So we can say nc2a square is equal to n into n minus 1 divided by 2 into a square. N into n minus 1 divided by 2 into a square. Is it clear guys? Yes. And it goes on like this. Let's find what is nc3 is equal to. Let's find one more term. What is nc3 is equal to, so you can understand it properly. Yes. So what is nc3 is equal to n factorial divided by n minus 3 the whole factorial into 3 factorial. Is it clear? Yes. So what is n factorial? We can write n factorial in the terms of n minus 3 factorial. How can we write? We can write n factorial as the product of n minus 3 factorial into n minus 2 into n minus 1 into n divided by n minus 3 the whole factorial into 3 factorial. So we can, these two terms will get cancelled. So here we have n minus 2 into n minus 1 into n. So we get n minus a square into n minus 2 into n minus 1 into n divided by 3 factorial, that is equal to 6a cube, plus it goes on like this. Is it clear guys? Up to this, is it clear? Yes. Now if the value of n is minus 1, if suppose the value of n is minus 1, that is you are asked to find 1 plus a the whole power minus 1. So what is the, how do you find what is 1 plus a the whole power minus 1? You have to substitute the value, you have to substitute this minus 1 in the place of, you have to substitute this minus 1 in the place of n. Yes. So yes, we know 1 plus, what is the value of n? Minus 1 into a. 1 plus minus 1 into a. Again we have minus 1 into minus 1 minus 1 into a square divided by 2, into a square divided by 2. Again you have minus 1 minus 2, here the sign is plus, minus 1 minus 1 minus 1 a cube divided by 6, and it goes on like this. Is it clear guys up to this? Yes. Now I am going to solve this. So we will get what is a 1 plus a the whole power minus 1. So the first term is obviously 1 minus a, minus 1 into a is equal to minus a. Here we have minus 1. What is minus 1 minus 1? That is minus 2. Since we are multiplying two negative terms we know minus into minus is plus. So we will get plus 2 the a square divided by 2. Both these 2's will get cancelled. So here we will get a square. Here we will get a square. Next, here we have minus 1 minus 2, that is minus 3. Minus 1 minus 1, that is minus 2, again minus. First you are multiplying two negative terms. So you will get a positive value. Minus 2 into minus 2 is equal to 6. Again you are multiplying a positive term with another negative term. So you will get a negative value. So here you have minus 6a cube divided by 6. Both these 6 will get cancelled. So this term is actually minus a cube. So we can generalize. We can generalize this by writing all the even powers are positive and all the odd powers are negative. We can generalize this particular expansion. We can generalize this particular expansion as all the even powers are positive. All the terms having even powers are positive and all the terms having odd powers are negative. Is it clear guys? So what is a 1 plus a the whole power minus 1 is equal to 1 minus a plus a square minus a cube plus a power 4. It goes on like this. Is it clear? Yes. So this is the equation. This is the equation that we require. This is the equation that we require for finding how the errors get combined. This particular equation, 1 plus a the whole power minus 1 is equal to 1 minus a plus a square minus a cube. This particular equation is required for us for finding how errors get combined when we are dividing two physical quantities. Yes. So is it clear up to this binomial equation, expansion, combination, how to find the combination of a number equation? Is it clear, guys, everything? Yes. So now let's see how errors get combined, when we are dividing two physical quantities. Let's see how errors get combined when we are dividing two physical quantities. Let z is equal to a by b, just like the previous cases, here also I am considering two physical quantities a and b, and in this case the resultant z is equal to measure of the physical quantity a divided by the measure of physical quantity b. I measured the physical quantity a and I got the measurement with some error a plus or minus del b. Again I measured the physical quantity del b and I got the measurement with some error, that is b plus del b. We know z is equal to measure of physical quantity a divided by measure of physical quantity b. Since we have errors in both of these measurements, yes, it is obvious that some error will occur in the resultant also. Let it be del z, and here in this case we have to find what is the maximum possible value of del z. Yes. Is it clear, guys, up to this? Yes. Now the next step is I am going to take a commonly outside from all the terms in the numerator, and I am going to take b commonly outside from all the terms in the denominator. How do we take a term? How do we take a value or number or variable, whatever it may be, outside commonly from all the terms? Suppose it is given 2x plus 2y plus 2z. Suppose it is given 2x plus 2y plus 2z. Here I have to take 2 outside. Commonly from all these terms. So how do I do that? I have to simply divide all the terms by the value. 2. Or we can say I have to divide all the terms by the value that I am planning or that I have to take commonly outside. Is it clear? Here the value I have to take commonly outside is 2. So I am dividing all the terms by 2. So I got 2 into x plus y plus z. So what are x, y and z? X, y and z are nothing but the value I got after dividing the term by 2. When I divide 2x by 2, I got x, 2y by 2, I got y, 2z by 2, I got z. Is it clear? Yes. Let's see one more example. Suppose, say for example, it is given 4x plus 8y plus z. If it is given like this, here also I have to take 2 commonly outside from all the terms. So how do I do? 2 into 4x by 2, 8y by 2 plus z by 2. What is 4x by 2? 2x plus 4y plus z by 2. Is it clear, guys? These all are simple maths. Yes. And we have learned all these things. We have learned all these concepts during our school days, isn't it? Yes. Here also I am going to take a from each and every term. So I will get a into a divided by a plus or minus a divided by a. And from the denominator I am taking b commonly outside from all the terms. So b by b plus or minus del b by b. Both of these a will get cancelled and both of these b will get cancelled. So I will get a into 1 plus del a by a. 1 plus del a by a into b plus or minus, not b into 1 plus or minus del b by b. Is it clear, guys, up to this? Yes. Now I am going to rearrange these terms. Like this. A by b. I am writing a and b together as a by b, and I am going to write both the other terms together, that is 1 plus or minus del A by A divided by 1 plus or minus del B by B. Is it clear, guys? This step, the last step, is it clear? We simply rearranged the terms. I wrote together A and B together and the other two terms together. Is it clear? Yes. Here, if suppose it is given x divided by y. If suppose it is given x divided by y, you can write this x divided by y as x into 1 by y. Isn't it? It is given x divided by y. You can write this same fraction, or you can write this same equation as x into 1 by y. Both these are equal. Both of these, or the values of both these terms are equal. We can otherwise write this term as x into y inverse. Isn't it? X by y is equal to x into 1 by y. We can otherwise write 1 by y as y inverse. Is it clear? Here also you have two terms. 1 plus or minus del A by A and 1 plus or minus del B by B. Just like in the form of x by y. So I can write this term, I can rearrange, or I can write these two terms as 1 plus or minus del A by A into 1 divided by 1 plus or minus del B by B. Is it clear, guys? Yes, I simply wrote this particular term in the form, I simply wrote this particular term, that is in the form of x by y into x into 1 by y. We can say these two terms are in x by y form, isn't it? I simply wrote these two terms in the form of x into 1 by y. Is it clear? Yes. So now, as I told before, we can write x into 1 by y as x into y inverse. So here also I can write a by b into 1 plus or minus del A by A into 1 plus or minus del B by B, the whole inverse. Is it clear, guys? Up to this, is it clear? Yes. So let's see a quick recap. Recap up to this, and then we'll move on to the next step. Here we are considering, or here we have to find the maximum possible error arising or occurring in the resultant when we are dividing two physical quantities. So here I considered two physical quantities A and B, whose measurements are A plus or minus del B and B plus or minus del B respectively. Is it clear? Yes. So I got the equation as Z plus or minus del Z is equal to A plus or minus del A divided by B plus or minus del B. Here I took the value A commonly outside from all the terms in the numerator, and I took the value B outside commonly from all the terms in the denominator. Is it clear? And I got the value, or this particular equation now become A divided by B into 1 plus or minus del A by A divided by 1 plus or minus del B by B. Is it clear? I simply rearranged these terms. I wrote A and B together as A by B and the other two terms, remaining other two terms together. Is it clear? Now, these two terms are in the form, these two terms are in x by y form. If two terms are in x by y form, we can write those two terms like this, that is x into 1 by y, and we can write x into 1 by y in another form, that is we can write 1 by y as y inverse. So that is what I did here. I wrote this 1 plus or minus del A by A divided by 1 plus or minus del B by B, like this, 1 into 1 plus or minus del B by B. Now I wrote 1 plus or minus del B as 1 by 1 plus or minus del B by B as 1 plus or minus del B, the whole inverse. Is it clear? Yes. Now here we got the power as minus 1, isn't it? Here we have to find, here we have to we have to expand this particular equation. Here we have to expand this particular equation using the concept binomial equation. Yes. We learned 1 plus x the whole inverse, 1 plus x the whole inverse, or we can say 1 plus x the whole to the power minus 1. We got the value as 1 minus x plus x square minus x cube plus x power 4 minus, it goes on like this, isn't it? Yes, just now we discussed what is 1 plus x the whole inverse or 1 plus x the whole to the power minus 1. We got the value, or we got the expanded form as 1 minus x plus x square minus x cube plus x power 4 minus etc. It goes on like this. All the even powers, all the terms having even powers will be positive and all the terms having odd powers will be negative. Is it clear? Yes. Now here we have del b by b in the place of x, isn't it? Here we have del b by b in the place of x. 1 plus or minus del b by b the whole power minus 1. So here I will get 1 minus del b by b. I will get 1 minus del b by b plus. Here I can write, instead of writing simply minus, I can write minus or plus. Again here I can write plus or minus del b by b the whole square. Again I can write minus or plus del b by b the whole power cube. Again I can write plus or minus del b by b the whole power 4. It goes on like this. Is it clear, guys? Up to this, is it clear? Yes. Now so I am rubbing all these. Yes. Now I am rubbing all these. Is it clear, guys, up to this step? Yes. Now here we have del b by b the whole square, isn't it? Here we have del b by b the whole square. What does it mean? It means del b by b into del b by b, isn't it? Del b by b into del b by b. Yes. Now we know del b is comparatively small. Del b is comparatively very small than b, isn't it? Yes. Here we are multiplying del b. Here we are multiplying two extremely smaller values. Here we are multiplying two extremely smaller values. So here we will get even more smaller value as the answer. Suppose, say for example, let it be del c. We can say del c is very very smaller than del b. Again we are now dividing this del c by the product of b. The product of b is, that is b into b. Value of b is very larger compared to del b, and we are multiplying two extremely larger values, so we will get even more larger value. Let it be c. Yes. Again here we are dividing an extremely smaller value by an extremely larger value. So again we will get an extremely smaller value in this case. Is it clear, guys? Yes. Is it clear? Yes. So when we divide an extremely smaller value by a very large number, yes, it is obvious that you will get an extremely smaller value which has a very little or no effect, in the value of 1 minus or plus del b by b. Is it clear, guys? In the value of 1 minus or plus del b by b. So here you can neglect all the terms starting from del b by b the whole square up to the end. Is it clear? Here you can neglect all the terms starting from del b by b the whole square to the end. Is it clear? Yes. So we can say, what is 1 plus or minus? What is 1 plus or minus del b the whole inverse? We can say that is equal to 1 minus or plus del b by b. So now we got the value of 1 plus or minus del b by b, the whole inverse as 1 minus or plus del b by b, isn't it? So now the equation becomes, now this particular equation z plus or minus del z becomes a divided by b into 1 plus del a by a into 1 minus or plus del b by b. Now guys, up to this, yes. Now I am going to multiply, or now I am going to open these two brackets. Now I am going to open these two brackets. How do we open brackets? How do we open brackets when we are multiplying two terms? We have to multiply each and every term in one bracket to all the other terms in the other bracket. So we will get 1 into 1 as 1. Let a by b remains there, 1, and 1 minus or plus del b by b, 1 minus or plus del b by b, again del a by a plus or minus, again I got plus or minus or plus, anyway you can write del a by a into del b by b. Here also we can say del a and del b are extremely smaller values, and del a and b are extremely larger values. When we multiply two extremely smaller values, we will get even more smaller values, and when we multiply two larger values, yes, we will get even more larger values. Again, when we are dividing extremely smaller values by extremely larger values, we will get even more smaller value. So this particular value has a very little or no effect on the value of the other three terms, or on the value of the z. Is it clear? Yes. So we can neglect this particular term. Now the equation becomes z plus or minus del z is equal to a by b into 1 minus or plus del b by b plus or minus del a by a. Is it clear? Yes. Is it clear up to this? Let me rub all these off. Now let me write the equation. Let me write the current status of the equation. Z plus or minus del z a by b into 1 minus or plus del b by b plus or minus del a by a. Is it clear up to this? Now I am going to divide the whole term by, on both the sides I am going to divide by z. Okay. I am going to divide all these terms by z. So when I divide z by z, I will get 1. When I divide del z by z, I will get like this. Here we can say z is equal to a by b, isn't it? So I am going to substitute the value of z as a by b divided by a by b. When we are dividing two fractions, we can say, yes, we have to take the inverse of the second term and multiply with the first term, isn't it? Yes, that is, suppose if it is given x divided by y into a by b. So how do we perform this operation? X divided by, I have to take the inverse of the second term a by b, that is b by a, and I have to multiply the inverse of the second term with the first term. So that is what I did here. These two b's will get cancelled and these two a's will get cancelled. Is it clear? Yes. So now this particular equation becomes 1 minus or plus del b by b, 1 minus or plus del b by b and plus or minus del a by a. We have 1 on both the sides of the equation with same sign, so we can cancel these two terms. So we can say del z by z is equal to del b by b. Is it clear, guys? Yes. Just like in the case of multiplication, in division also, when we are dividing two physical quantities, we can say the relative error, what is del z by z? It is the relative error in the resultant. And what is del b by b? It is the relative error in the physical quantity B or in the measurement B, and it is what is del A by A? It is the relative error in A. Is it clear? So the maximum, or we can say the maximum possible relative error in the resultant is equal to the sum of the resultant errors in the individual measurements. Here also we have to consider only positive values, because we know we will get maximum value only when we add up. We get maximum value only when we add up the positive values of individual measurements, isn't it? So here you have to consider the positive values of the relative errors in individual measurements. You have to add up that individual measurement to find the maximum possible relative error in the resultant. If suppose you are asked to find del Z, so how do you find that? Del Z is equal to Z into del B by B plus del A by A. Is it clear, guys? Is it clear? How do we find the error, maximum possible error in the resultant when we are dividing two physical quantities? Yes. So this is how we have to derive, or this is how we find the error in the resultant when we are dividing two physical quantities. Yes, the division process or the derivation is actually quite a little bit complicated, but I hope everyone understood it properly. If you have any doubts, yes, please feel free to ask in the comment section. I have explained each and every step in detail. I hope you all understood it properly. If you have any doubts, yes, please feel free to ask in the comment section. Yes. So is it clear, guys? Yes. Now let's see the last case. Now let's see. Okay, before going into the last case, let's see an example, an easy example. Suppose I am going here, I want to find the speed. Here I want to find the speed of a bike or car or whatever it may be. You are provided with two physical quantities, that is distance and time. We know speed is equal to distance by time. Let the value of distance be 25 km plus or minus 0.57 km. And let the value of time be 96 hours, not 96, 3 hours plus or minus 0.4 hour. Okay, yes. Here I have to find the maximum possible error. Here I have to find the maximum possible error in the speed. Here we know speed is equal to distance by time. So here I am dividing two physical quantities who have errors in their measurements. So I know relative error of speed is equal to sum of the relative error in distance and the relative error in the time. Is it clear? Yes. So del D is given as 0.5 km divided by distance is equal to 25. Now it is also given del T is equal to 0.4 divided by what is T, that is equal to 3. So what do we get? (0.57 divided by 25). So relative error in distance is 0.0228 plus 0.4 divided by 3, that is equal to 0.133. Okay. So 0.0228 plus 0.133, that is equal to 0.1561. So the relative error in speed, the value of relative error in speed is nothing but 0.1561. But here we are asked to find what is del S is equal to. So we know del S is equal to S into the sum of relative errors of individual measurements. What is the value of S? S is nothing but actual speed. How do we find actual speed? Actual speed is equal to actual distance divided by actual time. So actual distance is given as 25 divided by time, that is equal to 3. So again here got the value as 25 divided by 3, that is equal to, the actual speed is equal to 8.33. So once we multiply or once we find the product of these two terms, we will get the value of del z. Is it clear, guys? Yes. So now let's see the last case. Now let's see the last case in combination of errors, that is powers. Now let's see the last case, that is equal to, that is powers. So here let it be z is equal to, here let z is equal to a power x. Here let z is equal to not a power x, let it be 2 a square, not x. We will generalize it afterwards. So here it is given z is equal to a square. Okay. Here I measured the physical quantity a, I got the value as a plus or minus del a. Since there is some error in the measurement of a, we can say, so obviously there will be some error in the resultant also. So our equation will be like this, isn't it? Yes. So here I have to find what is the maximum possible value of del z. Now I can write del a, or we can write a plus or minus del a the whole square as a plus or minus del a into a plus or minus del a, isn't it? Say for example, if it is given x square, what is it is equal to? X into x. If suppose it is given x power 4, what is it is equal to? 4 times we have to multiply x. So here we have to multiply a plus or minus del a 2 times. A plus or minus del a. Now I am going to open these two brackets. Yes. So I have to multiply each and every term in the first bracket to all the terms in the second bracket. So I will get a into a square plus a into del a plus a into del a plus or minus del a into a, again plus or minus del a into del a. Here we can say del a is an extremely smaller value, again del a is an extremely smaller value. When we multiply to extremely smaller value, the value we get will have will have only a very little or no effect on this particular term, on this particular value. So we can neglect this value, is it clear? So now the equation becomes z plus or minus del z is equal to a square plus a into del a plus a into del a plus or minus a into del a. Is it clear, guys? Yes. Now we know z is equal to a square. So we have same terms, or we have same values on both the sides of the equation. So we can cancel both of these terms. So we will get del z plus or minus del z is equal to a into del a plus or minus a into del a. Is it clear up to this? Now I am going to divide the whole term. Whole equation by z. So when I divide del z by z, yes, I will get the relative error. In the resultant z. So here instead of dividing these two terms by z, I am going to divide these two terms by a square, because we know z and a square are one and the same. When I divide this particular term by a square, so here I am going to divide both these terms by a square. So I will get plus or minus del a by a plus or minus del a by a. So what is plus or minus del z by z is equal to plus or minus del a by a and plus or minus del a by a. Here we have two similar terms and we are adding up those two terms. Suppose it is given x plus x. How can we write it? Simply 2 into x. Suppose it is given x plus x plus x plus x plus x. How can we write? I have to count the number of x, 2, 4, 5. So I can write 5 into x, that is equal to 5x. Here we have two similar terms and we are adding up those two terms. So I can say 2 into plus or minus del a by a. Is it clear, guys? Yes. Here we have to, for finding or for getting the maximum possible error, we have to consider the positive measurement. So here we can say 2 into del a. So what is What is the relative error? What is the relative error in the resultant when we are finding powers of physical quantities? What is the relative error? What is the relative error in the resultant when we are finding powers of physical quantity? We can say the relative error in Z is equal to power value into relative error in individual measurements. Power value into relative error in individual measurements. Is it clear, guys? Yes. So how do we generalize? Suppose Z is equal to A power X. Suppose it is given Z is equal to A power X. I can say the relative error in the resultant Z, that is del Z by Z, is equal to X into del A by A. X into del A by A. So is it clear, guys? Yes, up to this. Now